Hi students, this is Dr. Joe Angley back with our second lecture video on climate change. In this video we will be learning about how climate has changed over time, and we will also be looking at the nature and cause of recent climate changes. So our learning outcomes include developing an understanding of how climate changes over time and the factors that can create natural variability in climate. In many parts of the world, climate change is a largely accepted fact. However, in some political circles, particularly in the United States, climate change remains a topic of debate. As we will see, however, climate science has firmly established that climate change is occurring at a fairly rapid rate, is irreversible over the near term, and is an important issue to address to avoid further damage to Earth systems. This graphic shows a survey of U.S. citizens on the topic of climate change. While the majority of Americans believe in anthropogenic, human-caused, climate change, a sizable number of people have doubts. This is exacerbated by politicians and the fossil fuel industry, who are among the most vociferous climate change deniers. It is critical to address the issue of climate change, as the window of opportunity to address climate issues is quickly coming to a close. One important thing to keep in mind is that there is a significant difference between climate and weather. Weather occurs over short time periods in specific locations, and we expect a certain amount of variability. Climate, on the other hand, occurs over large regions and long timescales, and we expect climate to remain relatively stable over a scale of hundreds and thousands of years. When climate changes abruptly, as it can sometimes do, this is often a significant event. Every time it snows, small amounts of air are trapped in the snow layers. In Greenland and Antarctica, and other places where cold is persistent, yearly snows accumulate slowly over the centuries. New layers compress lower layers into ice. But still, tiny air bubbles remain, even thousands of meters deep into glacial ice. Each bubble is a tiny sample of the atmosphere at the time that snow fell. Climatologists have discovered that by drilling deep into an ice sheet, they can extract ice cores from which they can collect air bubble samples. Samples taken every few centimeters show how the atmosphere has changed over time. Ice core records have revolutionized our understanding of climate history. We can now see how concentrations of atmospheric carbon dioxide have varied and detect ash layers and spikes in sulfate concentrations that record volcanic eruptions. Dr. Mark Twickler of the University of New Hampshire holds a section of the 3,000-meter Greenland ice sheet core, which records 250,000 years of climate history. This graphic shows the variability of the Earth's climate over the past 550 million years. The Earth is generally cooler now than it has been in the past. Recently, the European Project for Ice Coring in Antarctica, EPICA, has produced a record reaching back over 800,000 years. These cores not only show that climate has varied dramatically over time, but that there is a close correlation between atmospheric temperature and carbon dioxide concentrations. From these ice cores, we know that carbon dioxide concentrations have varied between 180 to 300 parts per million in the past 800,000 years. Therefore, we know that today's concentrations of approximately nearly 400 parts per million and rising at about 2 parts per million per year are about one-third higher than the Earth has seen in nearly a million years. Concentrations of methane and nitrous oxide, two other important greenhouse gases, are also higher than in any records in the EPICA sample. We also know from oxygen isotopes that present temperatures are nearly as warm as any in the ice core records. Further, warming in the coming decades is likely to exceed anything ever seen by our species, Homo sapiens, which appeared just 200,000 years ago. Observe the graphic carefully. How does the temperature and carbon dioxide concentration compare in recent times compared to past data. This graphic shows that over the last 800,000 years, the pre-industrial concentration of carbon dioxide is 278 parts per million. As of February 2016, the atmospheric concentration of carbon dioxide is 404 parts per million. One of the questions that was posed in our initial survey was if climate change is caused by humans, or if it's a natural phenomena. Let's find out. Based on the data from ice cores, we know that climate definitely changes over time. Some, but certainly not all of the climate's variability is caused by natural events or natural forcings. Other factors in climate variability are anthropogenic. We can identify several natural factors that may contribute minor changes in the Earth's climate system. These include those listed in this slide. If you want to see an interactive demonstration of the various contributions from some of these, follow the link provided in the text box. Modest changes correspond to a cycle in the sun's intensity, which peaks about every 11 years. However, as shown in the graphic, there is no correlation between sun cycles and global surface temperature, so our observed global warming must be from something else. More dramatic changes are associated with periodic shifts in the Earth's orbit and tilt. These are known as the Milankovitch cycles, after the Serbian scientist Milutin Milankovic, who first described them in the 1920s. There are three of these cycles. A, the Earth's elliptical orbit stretches and shortens in a 100,000-year cycle. B, the Earth's axis changes its angle of tilt in a 40,000-year cycle. C, over a 26,000-year period, the axis wobbles, like an out-of-balance spinning top. These cycles cause variations in the intensity of incoming solar energy at different latitudes and in the intensity of summer heating or winter cooling. The oceans absorb heat created by incoming solar radiation. Ocean currents act as a global conveyor system, redistributing warm and cold water around the globe. These currents moderate our climate. For example, the Gulf Stream keeps northern Europe much warmer than northern Canada. Variations in ocean salinity and density help drive ocean circulation. These deep ocean currents are critical to life and to maintaining the Earth's current climate. These currents, also known as the ocean conveyor, can take hundreds of years to migrate around the planet. Climate data indicates that there is no positive correlation between volcanic eruptions and a warming planet. In fact, there is a negative correlation. Volcanoes produce copious amounts of sulfur dioxide, which actually cools the atmosphere for several years. Human activity puts about 100 times more carbon into the atmosphere than volcanoes on an annual basis, so volcanic activity is not to blame for recent temperature changes. Sulfur dioxide does contribute to acid rain, however. The El Niño Southern Oscillation, ENSO, is a naturally occurring climate event that happens on a 5 to 7 year cycle. On the scale of years or decades, the climate also changes according to oscillations in the ocean and atmosphere. These coupled ocean-atmosphere oscillations occur in all the world's oceans, but the El Niño Southern Oscillation is probably the best known. ENSO affects weather across the Pacific and adjacent continents, causing heavy monsoons or serious droughts. The core of this system is a huge pool of warm surface water in the Pacific Ocean that sloshes slowly back and forth between Indonesia and South America, like water in a giant bathtub. Most years, steady equatorial trade winds hold this pool in place in the western Pacific. From Southeast Asia to Australia, this concentration of warm equatorial water provides latent heat that drives strong upward convection in the atmosphere, resulting in heavy rains in Indonesia that support dense tropical forests. On the American side of the Pacific, cold upwelling water along the South American coast replaces westward flowing surface waters. This upwelling deep water is rich in nutrients. It supports dense schools of anchovies and other fish. In the atmosphere, Dry, sinking air in Mexico and California replaces the air moving steadily westward in the trade winds, resulting in dry conditions in the southwestern United States. In conclusion, we have learned that the Earth's climate system is variable. We have seen that carbon dioxide concentrations are closely and directly related to temperature, and we have data from over 800,000 years of Earth history to prove the relationship. We have also seen that the recent changes in carbon dioxide and temperature are not related to some of the natural sources of climate variability, because man's input of carbon dioxide dwarfs these minor changes.